Alright, welcome back again to this course in ABE161, and this video will be discussing the topic on tributary area. In the previous videos we discussed the different types of loads and the loading combinations actually. So if there's a dead load and a live load that's acting simultaneously to a structure, then how do we compute them? And we've studied that in order to determine the maximum values, we have to check the different loading combinations. Of course, for example, in some loads, like for example, dead load only, then um, you have a 1.4 dead load combination, and for dead load and live loads, you can also check the load combination one and then the second combinations. But usually, um, a certain combination governs for a particular type of loading combinations. Okay, so for example, if there's a deadline and live loads, then you have to, usually what governs is the 1.2 dead plus 1.6 live. So something like that. Okay, so now our video will focus on, okay, let's apply those structural loads. But then how do we calculate the specific, uh, let's say, the specific loads acting on a structural member? So let's say we have a slab and there's a dead load and live load, and the slab is supported by a beam. So how do we determine this, or how much dead load, or how much, let's say, combined load is or factor loads that's contributing to this floor beam? Okay, so that's the topic on tributary area or tributary width. Okay, so tributary area is the loaded area that contributes to the amount of load a member will carry with respect to the other members. I carry with respect to the other members. Okay, so usually we can think of it as the halfway. Okay, so halfway to the adjacent member. Okay, so for example, we have a floor slab. Okay, so slab is, let's say, let's draw first the floor frames. Um, okay, so we have this floor frame over here. Okay, and we have a small beam that rests on a larger beam, or let's say a beam that rests on a girder. And we have these slabs on top. Okay, so let's make a sheeted area. Okay, so we have this slab and it's being supported by the small beams, and then the small beams transfers the loads the um, to the larger beam. Okay, so the question is how much, for example, with this given area and loadings, then um, how much how much load does this member carries, for example? Okay, so if, we'll try to draw the top view. Okay, so we have this girder and we have these beams, and we have this slab. Okay, so the question is how much load will this member carry? Will this beam carry? So we say that the tributary area is something like halfway to the adjacent member. Okay, so for example, this is the adjacent member, and of course we can draw another adjacent member here. Okay, so meaning halfway, that's gonna be half, and then another half on the other side. Okay, so meaning this loaded area, that's the amount of area that the beam will carry. Okay, so that's just the general description of this tributary area. But later on, we'll go into the details. Like for example, we have a two-way slab. Then, um, how are we going to distribute the loadings? And for example, walls supported by beams, or walls supported by uh, let's say by columns. Okay, so for steel structures, let's say for example warehouse, we have this example, we have these steel columns, right? And we have a gear, okay, something like a purlins. And let's say we have another I-beam here, or let's say I-shape member. Okay, so we have this purlins, and then we have a wall cladding. Okay, so if we let's say we try to look at in a elevation view, this is our column, and then this is our next column, and then another adjacent column, and we have our gear. Okay, and then we have a roofing sheet. Okay, so let's just make a hatch here. Okay, so the question is how much load will this column carry? Okay, so that's going to be halfway from the other column. Okay, let's say C1, C2, then C3. Right, so halfway and then halfway here. Okay, so all the loads in this area um, will be passed to these columns. Okay, so now let's discuss the importance of this topic. Okay, so let's go back to this slab on on floor beams. Okay, so once you get this tributary area. Okay, so let's try to draw again in 3 dimensions. Okay, so we have dead loads and live loads acting on the slab. So dead load, the slab thickness, and let's say if you have electrical surveys or pipings for the plumbing stuffs. So you have the dead load plus you also have the live loads. And then how much load we can then draw this beam in terms of uh, something like this, right? So the area here, the halfway on both sides, then that's gonna be the loading on this beam. Okay, so we have the dead load, live load, and then we solve for the factored load. Let's say we have a distributed loadings, a factored 1.2 del plus 1.6 live. And then if we model this beam, like for example, a simply supported, or you can also model this as fixed support, then what you can get with this tributary areas, the typical problems that we have already encountered, right? So from these loadings, then you can obtain the shear and moment diagram, okay, and you can also determine the maximum moment and then the uh, maximum shear. So that's going to be the basis for the sizing of the members, right? So let's say V max, and then uh, here we have M max. Okay, so once you get this, then since this beam is actually supported by the girders, then you can also model this girder. Okay, so we have these point loads. So let's say we have point loads here. The reaction of this beam would be the point load on this girder, right? So let's say all of that beam has these point loads, then you can solve it. And if you'll include, like for example, the beam self weight, then you can include a distributed loadings. Then again, you can solve for the support reactions. So for the support reactions, it can be, let's say, simply supported, or if you'd like, fixed can both fixed supports. So you can just have an statically indeterminate structures, and then you use the software. So that's all. Okay, so we have, let's list down for now the different situations wherein this transfer of loadings or the concept of tributary area um, typically arises. So we have from slabs to beam, and we also have, for example, beams to girders. And also, it is also possible to have walls, walls to beams. So in this case, the walls to beams, meaning that the wall, let's say a CHB wall, rests on the beam. The previous example that we had is actually a wall resting on the girts, and then the girts are actually supported by the columns. Okay, so it's also possible to have slabs to column, so that depends upon the design. Uh, Girders to column, or let's say girders or beams to the columns. Okay, so example of this is, for example, uh, you have this girder and you have small beams here. Then this girder is actually supported um, by these columns. But there's another way to determine the loadings in the column is by these slabs to columns. Okay, so we'll discuss this in detail in the next few minutes. Okay, what else? Let's say the roofing. Let's say roofing sheets plus purlins to the trusses or rafter. Right, so let's discuss the slabs to beams. So slabs to beams, usually when we're referring to beams, um, what we need is the tributary width rather than the area. Okay, and for slabs to beams, this depends on, say, just write this, depends on the type of slabs. Okay, so we have one way and two-way slabs. Okay, so what's the difference? So actually, if this is our let's say our slab and this is our beam, then we have another beam here. So let's say beam 1, and then we have beam 2, beam 3, beam 4. Okay, so the difference between one way and two way is actually the ratio of long side. So let's say ly, that's the long side, the ratio of the long side all over lx, the short side. Okay, so if ly over lx is greater than 2, then that's going to be one way. So if ly over lx is less than or equal to 2, then that's going to be two way. So actually you can visualize this when we say that the ratio is greater than 2, meaning that you have a more rectangular in shapes. So something like this. Okay, so if you have a rectangular shape, then the loading distribution is, okay, so let's say this is a one-way slab, this is another one-way, so the loading would be halfway and then halfway on the other side. So let's say we want to determine the loading of this beam number 3. Okay, so all the loads on this area are the loads that's going to be carried by the beams. Okay, so we have something like lx over 2 here. So if this is lx, okay, and then let's say we have lx2, so we'll just have half of this length. Okay, so on the other side, if that's for example 4 meters, then 4 divided by 2, that's just 2 meters. Okay, so that's the one-way slab loading actions. Okay, so for two-way slabs, since we have it more on a square shape, then the loading is that from the corners we'll project a 45-degree. Okay, so another 45-degree here, and then 45-degree, that's something like this. Okay, so meaning that how much load will this beam carry will be this bounded area, this triangular area. Okay, so that's gonna be the loadings. Okay, so for this case, I mean for this beam number 2, so it will carry the loads and this triangular loads on the left side, and it will also carry the rectangular load on the right side. Okay, and for this, let's say we have this girder. So this girder will carry loads from the slabs, this trapezoidal, let's say this trapezoidal shape area. Okay, and plus of course we're gonna include the something like the point loads or the reactions from this beam 1. Okay, so that's gonna be the difference. Okay, so for this beam, let's say we'll draw this in a way that we usually encountered. Then this beam 1, we have, let's say we'll just do a simply supported beam. Okay, so the loading will be a triangular load. Okay, so for this girder, or let's just consider this point, and I mean from this point to that point, or let's just put a, let's say a column here. Okay, so that we can just isolate this beam. Okay, so for this beam, so we have a trapezoidal loadings. Okay, and then what else? Now for this beam sub beam number 3, then we just have this uniformly distributed loads. Okay. Okay, so since our loading is in, if you notice that our loading, dead loads and live loads, they are in actually in kilopascal, kilonewton per meter squared, and we have this distributed loading, meaning that what we need is we need to convert this to kilonewton per meter. So meaning instead of using the area, instead of multiplying this to the uh, area, we'll multiply this only to the width. Okay, so that's the tributary width. Okay, so you have these loadings. So let's say factored loads times the tributary width. Okay, so that this one is in kilonewton per meter squared, and then the tributary width is in meters. So the tributary width is from this point, from this beam to the halfway distance. Okay, so we have different, we actually have different tributary widths for, let's say, rectangular, trapezoidal, and triangular. Okay, so for this, our tributary width is just Lx, the short side, divided by 2. Now for this, if you notice, this distance is actually the tributary width. If you notice this, okay, so let's say from beam 1 and then to this maximum value here, or let's say the vertex, um, that's gonna be half of this. Let's say this is the short side, this is the long side, right? Ly, Lx, that's gonna be Lx over 2. Okay, so supposedly this maximum value is Lx over 2, and the same goes true with this tributary, I mean with these trapezoidal loadings. So we have Lx over 2. However, we have a reduced value. Instead of using this, we'll be using a reduced value because we need to simplify this into a uniformly distributed loadings. Okay, so the same goes true with these triangular loadings. So instead of Lx over 2, what we'll be using here is Lx over Lx over 3, and for this one, this is gonna be Lx over 6, right? So 3 minus Lx over Ly, so this is raised to squared. So please correct the ones that's written on the lecture handouts. The squared is on the outside bracket, but that's, I mean, the square should be on this term, the ratio Lx over Ly. Okay, so if you compute this, then that's gonna be lower than this Lx over 2. Okay, so instead of solving this in terms of trapezoidal loadings, then we can simplify it as a, okay, we'll just write it here. Okay, so you can simplify this as a uniformly distributed loads. Okay, so this is a simplification. And simplification. Okay, so um, in some situations, instead of calculating for this LX, let's say the tributary width for the triangular loadings and trapezoidal loadings, what they use is this value, the LX over 2, and then just simplify it to this uniform loadings. Okay, so but for us here in this course, we'll be using this tributary area. So in the next video, we'll be discussing one example for applying this concepts. All right, so see you in the next video.